All right, so we're going to be evaluating functions. Evaluating functions can be compared to a machine where each input, x, in the machine follows a rule to produce its output called f of x, which is essentially our y there. Two machine functions are given below. Use the given input values and function rule to find the output. So what I'm doing is I've input x into my rule, and I get an output of f of x, which is my y. These are my x values, those are my y values. So keep that in mind. So if I input 5, then I follow the rule 2x, which is 2 times 5. I get an output of y, which is 10. I multiplied. So then if I have an input x that I plug in and I get 2 times negative 3, 2 times negative 3 is going to give me negative 6, which is my y value. So I put in my input x and got an output y. When I come over to b, I can see that I had, again, that input x, followed a rule, and got an output, which again is going to be my y value. So if I have an input of 5, which is my x, I would do 5 squared plus 1, which is going to output my y of 26, because 5 squared is 25, and 25 plus 1 is 26. If I was to input negative 3, which is my x, I would have parentheses, a negative 3, because that's that whole value. Parentheses will actually be important when we're doing these. Squared plus 1 is going to result in negative 3 times negative 3, which is 9, plus 1, which results in a y value of 10. So we are inputting something and getting an output. When we're doing this, we have something called function notation. Function notation is f is the name of the function. F of x is read as f of x, as I said it, and is equal to our y, and x is the input value. So when we're doing this, we're going to write each of the rules from the function machine above using function notation. We would say f of x is equal to 2x, and f of x is equal to x squared plus 1. This is the rule that we followed. To evaluate, f of x is equal to 3x plus 9. For x equals 5, you're going to substitute 5 for the variable x, and then write f of 5, so this is where you would write it, and it would equal plugging in or substituting in that 5, 3 times 5 plus 9, therefore f of 5 is equal to 24. So this right here is telling you what to plug in. So let's practice what this means. So we have f of x is equal to 6, parentheses, x plus 9, parentheses. So this is our rule that we're going to follow. We're going to input a 4, which is my x, and so it would say 6 times 4 plus 9. Now essentially you can type this into Desmos, yes, but if we were to do this math, that's 9, 10, 11, 12, 13, that's 6 times 13, which is going to result in 78. And so if I was to move this to have a little bit of space for it, or rewrite it, it would be f of 4 is equal to 78. Whereas the next rule is going to be 6 times x plus 9, 6 times negative 6 plus 9. That would result in 6 times 3, and 6 times 3 is 18. So f of negative 6 is equal to 18. Now, even if it's not an f, g is still the name of the function, so it's the same process. We would have g of x is equal to x squared minus 12, so we would do x squared minus 12, which is 1 squared minus 12, and that's going to result in a negative 11. So we would say that g of 1 is negative 11. Again, you can use Desmos to type that in. We would do x squared minus 12, which is negative 3 squared minus 12, which is going to be 9 minus 12. And that's going to result in a negative 3. So g of negative 3 is equal to negative 3. Lastly, we have p of x is equal to 8 minus x divided by x. So we're going to do p of negative 8, which is going to be 8 minus x over x, which is 8 minus negative 8, and I'm going to use parentheses to keep it kind of organized, divided by negative 8. When I do that math, I get 16 over negative 8, and I would simplify that down to a negative 2. And again, you could type all of that into Desmos. Versus if we did 8 minus 8 over 8, it's going to result in a 0 over 8, which is just 0. Again, it's telling you what to plug in. All right, so we're going to evaluate each of these functions. I want you to pause the video and I want you to attempt these 3. If you pause the video, you should have found that we are plugging in 3 for x, and we would have 1/2 times 3 minus 6 minus 5 over 2. I would simply type that whole thing into Desmos, and when you do, f of 3 results in a negative 4 result. Given h of x is equal to 5 parentheses x plus 3 to the second power, you have to type everything in that way. What is the value of h of negative 5? So I would take my original rule, 5 times x plus 3 to the second power. You have to type in those parentheses to make sure that you get the right result. We would plug in the negative 5, 5 parentheses negative 5 plus 3 to second power. Again, essentially we're just doing the math that we've done in the past. When we type that in, we get h of negative 5 results in 20. Again, use Desmos. Lastly, we would have 3 times x squared minus 1 plus 7. If we're looking at plugging in negative 7, we would have 3 times negative 7 squared, because we want to square all of that, including the negative, minus 1 plus 7. If I was to do this math step by step, I would have 3 parentheses negative 7 times negative 7 is a positive 49 minus 1 plus 7. 49 minus 7 is 48. I'm multiplying that 3 plus 7. I'm going by my order of operations here. 3 times 48 is 144, and I'm adding 7, which is going to result in 151. So I would write g of negative 7 is equal to 151. All right, so we have the given function f of x is equal to x squared plus 10. What values of x would yield a negative output? So we can start plugging in any number, and I'm going to give an example. F of negative 5 versus f of 5. Well, when I plug those in, I have negative 5 squared plus 10, and I have 5 squared plus 10. Negative 5 times negative 5 is a positive 25 plus 10, which results in 35 after I add the 10. 5 squared is 5 times 5, which is 25, plus 10. It also results in 35. What you're going to notice is that no matter what I plug in here, I'm going to result in only positive numbers, and there's no way to get negative numbers, because when you multiply two of the same numbers, even if they're negative, it results in a positive. And since we're adding 10, then we can only have a positive result. So I put the explanation that I just said right there. Again, because that x squared is only going to get us a positive result or yield a positive outcome, then we know that we can only have a positive answer. Lino evaluated f of x for -9. Describe the error that he made and find the correct value. So when I'm looking through this, that's my rule. What I see the error being is already right here, and he did not put a -9. So at this point, it should have been 18 parentheses 2 minus a -9, which would have resulted in 18 times -7, which would have resulted in, I lied, that's not -7, that's an 11. And that would have resulted in 18 times 11, which is 198. So f of -9 is equal to 198. So the error was made of not putting in the negative. That's because the rule already had that subtraction, and that's where the error was made. All right, let's look at the next one. So the graph of y equals f of x is shown below. Find f of -4. So f of -4, this is my x value, and the whole outcome is going to be my y. So I'm going to go to where the x is a -4, which is going to be this axis. I'm going to keep going until I see where it crosses, which is right here, and that gives me a 6. So 6 would be my outcome. We have a florist, and a florist determines her monthly profit in dollars from selling bridal bouquets using the function p of x is equal to 15x squared minus 10.5x. What will her monthly profit be if she sells 12 bouquets? 12 being the x value or the input. So what we would do is we would have p of 12 is equal to 15 times 12 squared minus 10.5 times 12. If I was doing this math, it would be 15 times 144 minus 10.5 times 12, which is 126. Again, you can type this all in from left to right, but then we would do in Desmos, but then we would do 15 times 144 is going to give me 2,160 minus 126, and once I subtract that 126, I get 2,034. And that is going to be the profit. All right, Malcolm is shooting a free throw. The height of the basketball over time can be written as the function h of t, where h of t, which is our y value overall, is the height of the ball in feet, and t, which is our x value, is the time in seconds elapsed of the ball as it's left his hands. The function h of t is shown on the graph below. Write in words what the value of h of 0. So we're thinking about, why would h of 0 be right there? Why would the ball start at that height? Well, that's going to represent how tall or where the player is, or where the player is holding the ball. Now, what would happen at 0.8 seconds? Well, if you notice, your seconds are at the bottom and it's written in those decimal forms, so we would say 0.8 goes all the way up to that point right there, and when we go over to see what the height is, it's 10 feet. So as long as we can read that graph, we're good. All right, if you have any questions, please make sure you ask. Other than that, have a great day.